Hello Math 109 students, this is chapter 5, video number 3. We're picking up on number 24 where we left off last time. So to solve a higher order polynomial like this, that's kind of the apex of what this chapter is about. Find the zeros. That means we're setting this whole polynomial equal to 0, plugging 0 in for y to find the zeros. So I'll just go right to maybe the easy way to do this, the easiest way. I will go, one way you could do it is to go to the graph. I could type it into y equals and graph it and find where it crosses the x-axis by doing second calculate zeros, and I can find the zeros that way, the real zeros that way. Another way I could do it is with the apps. Go to apps and go to PolySimult. That's option 9. And then from this menu, I'm going to choose option 1, Polynomial Root Finder. The order, remember that's the degree of the polynomial, the highest exponent, which is 4 in this case. I think when you choose 4, it eliminates some of the options for you that you could choose if it was less than 4. But that's okay. I'm going to click next from here by clicking the button below next, which is the graph button. And then I'm putting in my coefficients right here. My coefficients for this guy are 2, -3, -112, 2. Oh, what is going on here? Okay, 2, enter, -3, enter, -112, 57, 56. Then I click solve. I click solve by clicking the graph button, which is the button below solve, and it tells me my answers. So I've got 4 answers here, and they're all real numbers. So, and the degree is 4. So I should have the same number of answers as I do the degree of the polynomial. So I've got 4. So all the answers are real in this case. 8, -7, 1, and -0.5. 8, -7, 1, and -0.5. So I can just type those in for the answer for the real zeros. But then it's going to want me in the next part, it wants me to use the real zeros of f to factor f. Now how do I turn these into factors? Well, it's pretty easy. For most of them, it's pretty easy. It's just going to be x minus 8, x plus 7, x minus 1. But this one, I have to treat it differently. All right. First of all, I'm going to make it into a fraction. Just trust me for a second. So it would be, if I change this to a fraction, it would be -1/2. So if I make that into a factor, it's going to be x plus 1/2. But I don't know if, I hope you remember that how we would take the number on bottom and move it in front of that particular x right in there, so that when I turn this into a factor, I actually am going to write it as 2x plus 1. If I set the 2x plus 1 equal to 0, I'm still going to get -0.5 as the answer. But you need to do that because that's the only way that you're going to get this 2 in front of the whole thing if you were to FOIL it out. So this should be what my answer looks like for the second part of that problem. This will be obviously the answer to the first part. All right, number 25. Okay, I'm going to solve this one by factoring. I can factor this one. Let me show you how you can factor this. 9x to the 4th plus 17x squared minus 2. I'm going to do a kind of a variation of the AC method, also known as the slip, slide, slip method. Hopefully you remember what that is. You take the A and you multiply it down there with the C. So I get x to the fourth plus 17x squared minus 18. Then I factor that. These two terms have to multiply to get that first term, so it's got to be an x squared and an x squared. And then these two terms have to multiply to get the last term and add to get the middle number. So that's going to be a positive 18 and a negative 1 to multiply to get negative 18 and add to get 17. Okay, then though, remember to put the 9 back up under here. That's why it's called the slip, slide, slip method. Remember, you guys slip it down there and then slide it back up under there. So if this will reduce, so that becomes x squared plus 2. This one won't reduce, so I have to slide the 9 back in front of that x squared, so that becomes 9x squared minus 1. Now, I can factor this a little bit more. This is good factoring, but I can factor this part some more because that's a difference of squares. 9x squared and negative 1 are both perfect squares, and there's a minus sign between them, so the x squared plus 2 will stay as it is, x squared plus 2. The 9x squared minus 1 becomes 3x plus 1 and 3x minus 1. So now I solve these things. I solve it by setting each one of these factors equal to 0. If I set x squared plus 2 equal to 0, subtract 2, x squared equals negative 2, take the square root of both sides, x equals plus or minus I root 2. Notice that this says find the real zeros. It says real zeros right there of f. So since what I just found here was an imaginary zero, I'm not even going to put that as part of the answer, because it's not part of the answer. So I am going to set 3x plus 1 equal to 0 and 3x minus 1 equal to 0. And I'm going to subtract 1 there, so 3x equals negative 1, divided by 3, and x equals negative 1/3. Here I will add 1, so 3x equals 1, divided by 3, x equals positive 1/3. So I can write my answers as negative 1/3, comma, positive 1/3, or you could just say plus or minus 1/3. But this is going to be the answer that I type in to the first part of this this problem. Let's type that in. Okay, I'm going to put plus or minus. Then I guess I need the fraction bar, don't I? 1/3. Check that, and that's correct. Then it says use the real zeros to factor f. All right, let me go back to where I was working on this. So, all right, I'm gonna leave this the way it is. X squared plus 2 is a factor, and then these two are both going to go back to their factored form, the 3x plus 1 and the 3x minus 1. Because if I write it as x plus 1/3, I'm going to have to take that 3 and move it back in front of that x anyway, so which puts me right back there. So 3x plus 1 and 3x minus 1. That should give us the answer there. Now you could have also done this in your calculator with the apps, and it should have also given you the answer. But if I can factor something, I just find that to be a simple way to do things. So if I can factor something, I'm going to go ahead and factor it usually. All right, let's type that in for the answer. Okay. X squared. Let's see how to do this with this keyboard. I went ahead and typed in the answer, so let's check it. That is correct. Moving on to the next one. All right, number 26. this one. Let's see. I would first want to check to see if this is factorable. Is there anything that multiplies to get 82 and adds to get 18? The only factors of 82 I can think of are 1 and 82 and 2 and 41. And neither one of those are going to add up to 18 at all. So I don't think it's factorable. So what am I going to use? Well, this is a quadratic equation. It's got an x squared in it. That's the highest degree. So I'm going to go ahead and use the quadratic formula. So negative 18 plus or minus the square root of negative 18 squared minus 4 times 1 times 82 all over 2 times 1. So that's going to be 18 plus or minus the square root of 324 minus 4 times 2 is 8. 8 is 32, 328 all over 2. So that's going to be 18 plus or minus the square root of negative 4 over 2, which is 18 plus or minus 2i over 2, which reduces to 9 plus or minus I. Right, if I divide everything here by 2, the 18 becomes a 9, that 2 becomes a 1, and that 2 down there becomes a 1. So it's just 9 plus or minus 1i, or 9 plus or minus I. All right, let's type that in. Make sure we're right. 9. Oh, I got 9 plus or minus I. That is correct. Okay, number 27. If 7 plus 5i is the zero of a polynomial function of degree 5 with real coefficients, then so is what? Okay, this is a pretty simple thing if you know what I'm about to tell you, that complex zeros always come in pairs. In fact, they always come in conjugate pairs. Conjugate pairs. What do I mean by conjugate pairs? I think we had a unit where we learned what conjugate means. Conjugate is when you just change the sign of the imaginary part. So if 7 plus 5i is one of the zeros, then that means that 7 minus 5i is also one of the zeros. They always come in conjugate pairs. They never come as a single entity. They always come as a pair. Complex, aka or imaginary zeros, always come that way. So let me type that answer in. That makes finding the answer very simple. So 7 minus 5i. Yep. A polynomial function of degree n with real coefficients has exactly n complex zeros. At most, n of them are real zeros. That is perfectly true. And I've alluded to this earlier in the video, that whatever the degree is, that is exactly how many total zeros you have. How many both real and imaginary zeros altogether, you'll have that many. You'll have, so if it was a 5th degree, you'd have 5 total solutions. Some of them may be real and some of them may be imaginary, but altogether it would add up to 5 total zeros. So this is true. And we're going to go ahead and put that in and say yes and go to the next one. Polynomial function of degree 4 with real coefficients could have -3, 1 plus I, 1 minus I, and -3 plus 7i as its zeros. Well, it's a degree 4, so it's got to have 4 complex zeros, but this is not possible. Why is this not possible? This is not possible because what we just said, complex zeros always come in pairs. That's good, but they're in pairs. But this one has to have a pair. And it doesn't have its pair. And it can't, because that's number 1, that's number 2, that's number 3, and that's number 4. So it can't have a fifth one because the degree is 4. And this one has to have its conjugate pair, and it doesn't. It can't. So this can't work. None of that can work. So the answer is false. All right, moving on. Number 30. Information is given about a polynomial whose coefficients are real numbers. Find the remaining zeros of f. This is a very simple one. The degree is 3. Let me get me a place where I can write here. The degree is 3. That means I have 3 total zeros. So one of my zeros is 9. That's number 1. Another one of my zeros is -5 minus I. That's number 2. So I got to have one more, and it just so happens that -5 minus I is one of my zeros. So that means I know that my other zero has to be the conjugate of that. -5 plus I. That's number 3. So that's the answer to this here problem. Type that answer in. -5 plus I. That is correct. Number 31. Form a polynomial with real coefficients having the given degree and zeros. So we got degree 4. And we have these zeros. We have 4 plus 4i. Do it up here so I have more room down here. We got 4 plus 4i. We got -1 with multiplicity 2, so it's -1 and -1 again. That's only 3 zeros. So what's the fourth one? Well, it's kind of like what we just said. These complex zeros always come in conjugate pairs. So if 4 plus 4i is a 0, then 4 minus 4i would also have to be one of the zeros. All right, so that one has to be understood to be one of the zeros as well. Now, this is going to be pretty complicated, so bear with me here. We have to now form the polynomial that has those zeros. So first I'm going to turn each one of these zeros into a factor. These two will be easy. Let me do those first. That's going to be x plus 1 and x plus 1. All right, but how do I turn these zeros into factors? Let me show you. To do this one, it's going to be x minus, and I got to subtract the whole thing, so I got to use parentheses, x minus 4 plus 4i. And then for this one, it's going to be similar, x minus 4 minus 4i. Then distribute your negative here and here. So that's going to become x minus 4 minus 4i. And this is going to become x minus 4 plus 4i. Because, you know, when you distribute this negative here, it's going to change these signs. Now, I have to distribute all of that with each other. So, the triple level distributive method. So, x times x. So, I'm doing this. So, that's going to be x squared minus 4x plus 4ix. Then I'm distributing the -4. -4x plus 16 minus 16i. Then I'm distributing the -4i minus 4ix plus 16i minus 16i squared. All right, let's simplify this thing a little bit. First, remember what I squared is? That I squared is actually -1. So this thing becomes just plus 16. there are also a lot of canceling out that's going to happen. That's a good thing. 4, positive 4ix and negative 4ix, negative 16i, positive 16i. When we clean this up, what do we have? We have x squared minus 8x plus 32. I believe that's what we have. Right, the minus 4x, the minus 4x, and the plus 16, and the plus 16. All right, I'm not done yet. That's probably the hardest part, but it's still not over. Got to go ahead and distribute that as well. And that's going to be x squared plus 2x plus 1 when I distribute and combine. And then finally, I have to distribute this with this. So I need some room to do that. Let me just write it right here. X squared plus 2x plus 1 times x squared minus 8x plus 32. So I got to distribute those two together, and let's see what we get from that. That's going to be x to the 4th minus 8x squared. No, minus 8x cubed plus 32x squared plus 2x cubed minus 16x squared plus 64x plus x squared minus 8x plus 32. Combine stuff. That we got x to the 4th. What is going on here? That is not what I want you to do. We got x to the 4th, and that makes minus 6x cubed, and that, and that, and that. 32 minus 16 is 16 plus 1 is plus 17x squared. Then we got that, and that makes plus 56x plus 32. And that, hopefully, I think I've already typed it in. And this is what I typed in earlier, and this was the right answer, and that is the same thing that I had in my work right here, I believe. I want to make sure. X to the 4th minus 6x cubed plus 17x squared plus 56x plus 32. 6x cubed plus 7x squared. Yeah, that's it. Good. All right. That was, I do not enjoy that problem too much, but it is important to know how to do it. Moving on to the next one. All right. Again, finding the complex zeros. I'll show you a couple of ways you can do this problem. Notice this one says find the complex zeros, not just the real ones. So we're going to do the imaginary ones and the real ones here. So, again, one way is in the calculator. Go to apps. Go to apps. Go to option 9. Then option 1. The order is 3 this time. I definitely want the a plus bi to be highlighted. Next, it's going to be a 1 for the x cubed, a 0 for the x squared, a 0 for the x, and a 27 for that constant right there. And then I just hit solve, and I get a good solution for the real one, but I get an irrational number for the imaginary one. So let me write these numbers down. -3, -3, and 3/2 plus or minus 2.6i. 3 halves plus or minus 2.6i. Now notice this says type an exact answer using radicals and I as needed. That means this is not going to suffice because it's not an exact answer, it's a rounded off answer. So I'm not going to be able to use that. I'm going to have to do it another way to find the exact answer. Okay, so I'm going to show you a couple of ways to do that. One is with synthetic division. We can put the -3 out here because we know that's going to work because that's one of my zeros. And I'm going to put 1, 0, 0, 27 in the box because that's the coefficients of this polynomial. 0 for the x squared, 0 for the x as placeholders. Add down, that's 1, multiply across, that's -3, add down, -3, multiply across, 9, add down 9, multiply across, -27, and 0. And we have to end up with 0 right here. If we don't, we've done something wrong because we know -3 is supposed to work there. All right, so what do I have left? I have x. Remember, this always starts one less degree than the degree I started with. So it started with an x cubed. So this is going to be an x squared, and then an x, and then a constant. And this is the remainder. So it's going to be 1x squared minus 3x plus 9. And so now it's down to a quadratic. I know I can solve a quadratic all day long, right? We can either factor it, and if we can't factor it, we can always do the quadratic formula. This one is not factorable. Nothing multiplies to get 9 and adds to get -3, so I'm going to go to the quadratic formula. -3 plus or minus the square root of -3 squared minus 4 times 1 times 9 all over 2 times 1. That's going to be 3 plus or minus the square root of 9 minus 36 over 2, which is, let's go up here, which is 3 plus or minus the square root of -27 over 2, which is 3 plus or minus, let's see, 27 breaks down 9 times 3, 3 times 3, so I got a pair of 3's and an extra 3. That's over, so that's 3 plus or minus 3i square root 3 over 2. Okay, I think I should be able to type in the answer like this. So, but I may have to break it up. I think this is okay, but if I have to break it up, it's going to be 3 halves plus or minus 3 root 3 over 2 I. So may have to type it in like that. I'm going to check and see. But those are my answers. Now let me show you another way to do it. Remember, so my answers are -3 and then these 2 answers as well. All right, let me show you another way to do it. Another way to do it is if you know how to factor the sum of cubes or difference of cubes, sum of cubes or difference of cubes. So perfect cubes here. So if we have the sum of cubes is if we have like a cubed plus b cubed, then it'll factor as this pattern. It'll be a plus b, and then a squared minus ab plus b squared. Difference of cubes is very similar. If it's a cubed minus b cubed, it's a very similar pattern. It's going to be a minus b, and then a squared plus ab plus b squared. One way to help you remember this, at least as far as the signs are concerned, is the acronym SOAP. Same, opposite, always, positive. So what that means is that the first sign in the pattern is the same sign as the sign in your problem. So since this is positive, the next sign is going to be the opposite of what the first sign was. So since the first one was positive, this one's negative. And then the last one is always positive. So same, opposite, always positive. It works for the negative one too. See, this one's minus. So if this one starts, it's also going to start with the same as what it started with. So minus, so same. And then the next one is the opposite of that. So the opposite of minus is plus. So same, opposite. And then the last one is always positive. Same, opposite, always positive. Now let's apply that pattern to our problem before us. Okay, so if I have x cubed plus 27, okay, the way that you do that is you got to think of what is the perfect cube root of x cubed, what is the perfect cube root of 27. The perfect cube root of x cubed is x. The perfect cube root of 27 is 3. So x plus 3, like that's the A and the B. All right, and then a squared is going to be x squared minus AB is going to be minus x times 3, so 3x plus B squared, so plus 9. So if this thing factors like this, then I just set this one equal to 0, and I get x equals negative 3, as we already saw. And if I set this one equal to 0, I've got to do the quadratic formula, which we've already done, and we get those answers we got before. So that's another way to do it and arrive at the same answer. I'm going to type the answer in and see if you can type it in, see what it requires to type in. All right, I typed it in the way that you see on the screen here. I'm going to check the answer. I think I wasn't supposed to have a negative in front. That 3/2. Let's check it now. That is correct. All right, so you can type it in like that. Let's move on. Oh yeah, use the complex zeros to factor f. This is going to be a little bit of an adventure to write this answer, but let me show you how to type it in. Actually, I'll show you how to write it before I type it in. Let's go back to our answers here. So it's going to be x plus 3, obviously, from that one. And then this is going to be, I'm just going to say x minus, and then parentheses, 3/2 plus 3 root 3 over 2i, and x minus 3/2 minus 3 root 3 over 2i. And if I type it in just like that, if I type it in just like this, it should say that that's right. I'm going to type it in and show you. All right, x plus 3, and then x minus 3/2 plus 3 root 3 over 2i. And x minus parentheses 3/2 minus 3 root 3 over 2i. And then let's just hope that's right. It is right. Okay, so just pay very careful attention to how these answers were typed in. I know sometimes it can be very frustrating because when you mistype one little thing, like don't put commas between these answers here because this is showing the factors. The factors are all multiplying together, so no commas between them here. On this one, there are commas between them because you're separating the actual answers. The zeros are separated by a comma. Okay. Let's go on to the next one. All right, this video is already 45 minutes long, so I'm going to go ahead and stop it here, and we'll pick back up with number 33 on the next video, which will be part 4.